Hello everyone, this is Mr. Appel, and today we're going to learn some cool stuff about parallel lines. So you see in the picture I have drawn a couple of parallel lines and cut those parallel lines with what we call a transversal. This line right here is called a transversal, and that's just a fancy word for a line that cuts through other lines, that intersects other lines. And what you should notice is that transversal creates groups of angles when it intersects the lines. So it creates this group of four angles up here when they meet, and then it also intersects and forms these four angles here. Now you already know some things about the first group of angles. You know, for example, that angle 2 and angle 4 are congruent because they're vertical angles, and vertical angles are congruent. You know that angles 1 and 3 are also very vertical angles, so they're congruent. You know that 1 and 2 are supplementary because they're a linear pair. They add up to 180. 2 and 3 are 180. They're supplementary. 3 and 4. Lots of things that you know about those. But what we're going to be interested in today is the relationship between these angles, 1, 2, 3, and 4, and these angles, 5, 6, 7, and 8. Before we can do that, we need to have some language to use so we can easily refer to them. So we're going to use some words to describe where those angles are relative to each other. We're going to do that in two ways. The first is going to be interior and exterior. So if you notice, these angles in here are in between the two parallel lines. In between the two parallel lines. So we call those interior angles. So 3, 4, 5, and 6 are called interior angles. Then we have the angles on the outside of the parallel lines, those up there and those down there, 1, 2, 7, and 8, and those are of course called exterior angles. Then we also have some angles where we're going to talk about how the angles are relative to each other on the transversal. So for example, angles 1, 4, 5, and 8, angles 1, 4, 5, and 8 over here are all on the same side of the transversal. Same with 2, 3, 6, and 7. Those angles are all on the same side. In this case, they're on the right side of the transversal. But then we can also have angles that are on alternating sides of the transversal. So for example, angle 1 up here and angle 7 down here are on alternating sides of the transversal. So putting it all together, we have some different names for angles. So for example, angle 3 and 5 are on alternating sides of the transversal, and they're both in the interior, so we'd call them alternate interior angles. So 3 and 5 are alternate interior angles, and 4 and 6 are alternate interior angles. Similarly, we're going to have alternate exterior angles. So for example, angle 1 up here and angle 7 down here are on alternating sides of the transversal, and they're on the exterior, on the outside of the parallel lines. So those are alternate exterior angles, along with 2 and 8. Then we also have pairs of angles that are on the same side. So for example, angle 3 and 6 are both on the interior, and they're on the same side of the transversal. So 3 and 6 would be same side interior angles, along with 4 and 5. And then you might have guessed that we also have same side exterior angles. So angle 2 and 7 would be same side exterior. 1 and 8 would be same side exterior. And the last type of angles that we're going to talk about, the last named type, are called corresponding angles. Corresponding angles are when we take an angle, we look at an angle in this group and an angle in the other group, and they correspond. In other words, they're in the same position. So, for example, angle 2, as I've just highlighted, angle 2 over there, is sort of in the upper right corner, upper right of the four angles in this group. So the angle that corresponds with angle 2 is angle 6. Angle 6, which is right there. They're in the same position. So that's what it means for angles to correspond. So corresponding angles in this case would be 2 and 6, also 1 and 5, 4 and 8 correspond. They're both underneath and to the left. And then 3 and 7. Now that we've got all those angles named, let's talk about what's interesting about them. So what you may have already noticed is some of those angles appear to be congruent. And in fact, the angles that look congruent in this figure are congruent. So for example, the corresponding angles, when those lines are parallel, angle 2 and angle 6 are congruent. But since we know 2 and 4 are congruent, and we know 6 and 8 congruent, we can conclude that they're all congruent. Similarly, if we look at what look like the bigger angles in this case, so angle 1 and angle 5, those are corresponding angles, and those are congruent. And angle 3 and angle 7, those are corresponding angles. So those are also, I'm going to use double bars so that it doesn't look like they're congruent to the others. So 1, 3, 5, and 7 are all congruent. 2, 4, 6, and 8 are all congruent. And the ones that aren't congruent are simply supplementary. You can see that 1 and 2 are a linear pair. They make 180 degrees, so they are supplementary. And all of the red and the blue angles are supplementary in this figure. So we can conclude from that alternate interior angles, alternate exterior angles, and corresponding angles are all congruent. They are all congruent. Okay? And then if we look at the other pairs of angles, the same side interior and the same side exterior, so for example 3 and 6, those are supplementary, 4 and 5 are supplementary, 1 and 8, and 2 and 7, those are all supplementary angles. Now some of the problems that you're going to see involving parallel lines and transversals, it's not always going to be so obvious where things are. So here's one example. So if you're looking at this, it may not be obvious to you that angles 1 and 2 are same side interior angles, but they are. So one thing that might help you to see that is simply turning your head, or I'll do that for you. I'm just going to turn the paper. And then I'm going to just extend those lines. If I take angle 1 and I just extend it, and I take the other part of angle 1 and extend it, and if I do the same thing with angle 2, notice now it looks like what we just saw. It looks like two parallel lines cut by a transversal, and 1 and 2 are same side interior angles. So since the lines are parallel, which these symbols indicate, then angle 1 and 2 are supplementary. So finally, let's apply this to a problem. So here we see another example of two parallel lines cut by a transversal, and see how we might solve them. So there's a lot of ways to go here, but the first thing I notice is that this 80-degree angle right here and this angle that's labeled 2y are corresponding angles. And since the lines are parallel, the corresponding angles are congruent. So if this one is 80, then this one must be 80. So we can say that 2y must be equal to 80, and we've got a simple equation to solve. Divide by 2, and y is 40. Similarly, well actually we don't even need to use any of those theorems we just saw, since this angle is 80 degrees, and this is a linear pair over here. We've got a linear pair right over here. That's a linear pair. I'm using my fancy little red pointer. So since that's 80, these two have to add up to 180, so this angle is 100, so x must be 100. And that's just an example, a simple example of how we'll use parallel lines to solve problems.